Hello dear friends, today we'll be talking about the sampling, sample design and sample size. When you conduct your marketing research about a group of people, it's rarely possible to collect data from every person in the population. Instead, you select a sample. The sample, as you know from statistics course, is a group of individuals who will actually participate in your research process. And to draw valid conclusions from your results, you have to carefully decide how you will select a sample that is representative of the group or of the population. Today we'll be talking about the sampling, and by the end of this chapter, you should understand and correctly use key sampling terms, understand why we sample in our research process, apply practical sampling concepts, make sure that you can differentiate between probability and non-probability sampling, decide on the appropriate sampling design for your research problem in your research project, and decide on an appropriate sample size. First, you need to understand the difference between population and sample. Population is the entire or total group of people that you want to draw conclusions about, whereas sample is a specific group of individuals that you will collect data from. The population can be defined in terms of geographical location, age, income, and many other characteristics. It can be broad or quite narrow. For example, if you want to make some analysis about the whole adult population of Kazakhstan as a country, this is the real broad population. Whereas if you want to focus on the consumer of the particular company or brand, it will be quite narrow population. Or for example, you want to focus on students in a single faculty of the single university, which is also an example of quite narrow population. It's important to carefully define your target population according to the purpose of your project. And if the population is very large, it might be difficult to gain access to the representative sample. The sampling frame is the actual list of individuals that the sample will be drawn from. Ideally, it should include the entire target population and nobody who does not belong to this population. For example, you are doing NPS feedback survey to identify loyal employees of Kaspi Bank among its employees, and your population is all 8,000 employees of the bank within Kazakhstan country. Your sampling frame is the company's HR database, which lists the names and contact details of every employee out of 8,000 employees. Sample size, as we can understand from its naming as the sample size, is actually the number of individuals you want to take as a sample from the group of people or the population. And this number depends on various factors, including the size and variability of the population and your research design. There are different sample size calculators and formulas used in research depending on what you want to achieve with this statistical analysis. In the sampling terminology, we have to highlight the four main terms used. First is a sample, which is the subset or some part of the larger population. Population, which is any complete group of entities that share common sets of characteristics. Population element, which is each individual person of the population, and census is an investigation of all the individual elements that make up the population. Just for your information, Kazakhstan based the rules of censuses created by the United Nations worldwide, and till this time we provided two censuses, and the third one is about collecting, and the results will be given in 2022. There are two types of sampling methods used, which are the probability and non-probability sampling. Probability sampling involves random selection, allowing you to make strong statistical analysis and result inferences about the whole group, whereas non-probability involves non-random selection based on convenience or other criteria, allowing you to easily collect data. Probability sampling means that every person of the population has equal chance to be selected. It's mainly used in quantitative research. If you want to produce results that are representative of the whole population, probability sampling techniques are the best choice for you. There are four main types of probability sampling: a simple random sample, systematic sample, stratified sample, and cluster sample. Simple random sample is used when every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on chance. For example, you want to select a simple random sample of 1,000 users of global mobile app. You assign a number to every user in the mobile app database from 1 to 1 million, let's say, and use a random number generator to select 1,000 numbers. Then another one is called the systematic sampling, which is quite similar to the simple random sampling, but it is usually slightly easier to conduct. Every member of the population is listed with the number, but instead of randomly generating numbers, individuals are chosen at regular intervals. For example, all employees of the company are listed in their alphabetical order in the sampling frame. From the first 10 numbers, you randomly select a starting point, let's say number 5. And from number 5 and onwards, every 10th person on the list is selected, like 5th, 15th, 25th, 35th, and so on. And you end up with a sample of 100 people. If you use this technique, it's important to make sure that there is no hidden pattern in the list that might skew the sample. For example, if the HR database groups employees by team and team members are listed in order of seniority, there is a risk that your interval might skip over people in junior roles, resulting in the sample that is skewed towards the senior employees. The third one is the stratified sampling, which involves dividing the population into subpopulations that may differ in several ways. It allows you to draw more precise conclusions by ensuring that every subgroup or subpopulation is properly represented in the sample. To use this sampling method, you divide the population into subgroups, call it strata, based on the relevant characteristic. For example, gender, age, income, or occupation, marital status, and so on. Based on the overall proportions of the population, you calculate how many people should be sampled from each subgroup. Then you use random or systematic sampling to select a sample from each subgroup. For example, let's say beauty stores, Mon Ami, I don't know, the like Beautymania, it's not that important, has loyal 900 females and 100 male customers in their database. You want to ensure that the sample reflects the gender balance among customers of this beauty store, so you sort the population into two strata based on gender, like females and males. Then you use random sampling on each group, selecting 90 women out of 900 women and 10 men out of 100 men, which gives you a representative sample of 100 people. The last one in probability sampling is called the cluster sample. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. If it is practically possible, you might include every individual from each sampled cluster. But if the clusters themselves are too large, you can also sample individuals from within each cluster using one of the techniques we've discussed before. This is called multi-stage sampling. So turning back to the cluster sampling itself, it is the good, method for dealing with large and dispersed populations, but there is more risk of error in the sample as there could be some substantial differences between clusters. It's difficult to guarantee that the sample clusters are really representative of the whole population. For example, let's say FlipKZ or I don't know, Wildberries has branches in 10 cities across Kazakhstan, and you don't have the capacity as the researcher to travel all of these 10 cities. But you can use a random sampling to select only 3 branches, 3 offices, and this will be your clusters. Let's say you want to visit 3 largest cities like Almaty, Nur-Sultan, and Shymkent, and these 3 branches and offices will be your clusters you choose for your research project to represent all these 10 cities. Now we turn to non-probability sampling. In a non-probability sampling, individuals are selected based on some non-random criteria, and not every individual has the same chance of being selected. This type of sample is easier and cheaper to access, but it has a higher risk of sampling bias. That means that the results you can have about the population are weaker than with the probability samples, and your conclusions may be more limited. If you use non-probability sample, you should still aim to make it as representative of the population as possible. Non-probability sampling techniques are often used in exploratory or qualitative research, whereas probability sampling is more useful in descriptive and quantitative research studies. In these types of research, the aim is not to test a hypothesis about a broad population, but to develop some initial understanding of the small or under-researched population. This non-probability sampling has main 4 types as convenience sample, purposive sample, snowball sample, and quota sample. And in convenience sample, we simply include the individuals who happen to be most accessible to us as the researchers. This is an easy and inexpensive way to gather initial data, but there is no way to tell if the sample is really representative of the population, so it can produce some generalizable results. For example, you are researching opinions about your brand or product among your clients just after they bought something in your store by completing a survey on the topic. This is a convenient way to gather your data, but as you only surveyed clients at the post-purchase moment, the sample is not representative of the clients who, for example, has an experience of using your product for a longer period of time. Another one is called the purposive sampling. This type of sampling is also known as the judgmental sampling, and it involves the researcher using the expertise to select a sample that is most useful to the purposes of the research project. It's often used in qualitative research where the researcher wants to gain some detailed knowledge about a specific phenomenon rather than make some statistical analysis. Or where the population is very small and specific. An effective purposive sample must have clear criteria and rationale for the inclusion. For example, you want to know more about the opinions and experiences of your consumers with using your product, so you purposefully select a number of consumers with different aging characteristics like lifestyle, income, marital status, occupation, to organize, let's say, focus group in order to gather a varied range of data on the experiences with your offerings, products, or services. The next one is called the snowball sampling. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. The number of people you have to access to snowballs as you get in contact with more people. For example, you are researching experiences of small businesses who does the business online using Instagram. Since there is no list of all small businesses who make money on Instagram, probability sampling cannot be applied here. You meet one businessman who agrees to participate in the research, and this businessman puts you in contact with other businessmen that he knows. That's how you recruit people to be the sample of the population. The last one is the quota sampling, which is also the type of non-probability sampling. This is the method where a sample of respondents with specific characteristics and traits for research is selected from the population of interest. For example, researcher wants to survey individuals about what smartphone brand they prefer to use. And the researcher considers a sample size of 500 respondents, and also he is only interested in surveying 5 regions in Kazakhstan. Here's how the researcher can divide the population by quotas. First, by gender. Half of them should be males and half of them should be females. Then the aging groups. 100 respondents from the generation Z, 100 respondents from the generation Y, 100 respondents from the generation X, and etc. Employment status like 350 employed and 150 unemployed people. And location, like let's say 100 responses per region in KZ. And depending on the type of research, the researcher can apply quotas based on the sampling frame. It's not necessary for the researcher to divide the quotas equally because this is not the probability sampling, and here depending on the purposes and some criteria of the researcher, he can divide and decide himself how many like proportions to take from each region he is observing, let's say. And it all depends on his or her need, whom to include and how to include, and etc. Uh, that's it for today. Thank you guys for listening. See you on our live sessions. Take care. Goodbye.